Hello students, welcome to EPG Pathshala. I am Professor Pankaj Madan from Faculty of Management Studies, Gurukul Kangri Vishwavidyalaya, Haridwar. Today we are going to talk on module Measures of Dispersion, and in this module we will be talking about mean absolute deviation, standard deviation, variance, coefficient of variation under the paper Quantitative Techniques for Management Decisions. We will be covering various topics, and in this we have, by this paper you will be able to understand the complete module with the contents like range, mean absolute deviation, computation of mean deviation, characteristics of mean deviations, uses of mean deviation, standard deviation, and how you compute or calculate standard deviation. Except this, you will also be knowing about the characteristics of standard deviation, uses of standard deviation, quartile deviation or semi-interquartile range. We will be talking about variance, then relative measures of dispersion, coefficient of dispersion, coefficient of variation, standard error, and also we will be talking about standard error of mean, or what can be the probable error in computation of the dispersion. Any measure of central tendency or average has its own limitations and give us an idea only about that central value of the set of observations around which all the observations have a tendency to lie, but it fails to give us any idea about the way in which they are distributed. There can be number of series, each of which has the same mean, but they differ from others in respect to the pattern in which the observations are distributed. To follow this point, consider the following series which is being shown here. Now, in series A, series B, series C and series D, you will find that they have the same mean, but you can see the pattern of data or how it has been written or the distribution of data in all the series is different. In the above series, we observe that arithmetic mean of every series is 9, but the pattern in which the observations are distributed is different in different series. In series A, the mean is 9 and all the observations are same. In series B, you can see the mean is 9 and the observations are scattered ranging from 6 to 12, but not in every no, it is not very much scattered. In series C, the mean is same with the value 9, but the observations are too much scattered ranging from 1 to 27. And in last series, the series D, there are only 2 observations, but still the mean is 9. So from the above example, it is quite obvious that for studying a series, a study of the extent of scatter of the observation of dispersion is also essential along with the study of the central tendency in order to throw more light on the nature of the series, because if different series like you have seen A, B, C and D having the same mean but their dispersion or their pattern of data is different. The following are the different measures of dispersion which are in common use. Range is the simplest measure of dispersion. It tells the difference between the highest and the lowest terms of a series of observations. Rather, you can say that it is the difference between the highest value and the lowest value in the data or in the population. Now, the question here is that why do we want to find out a range? Now, if you see in a class that there are different numbers in a subject, different students gain, and you want to know that, okay, what is the range of the marks in chemistry? So the lowest and the highest, the difference between the two marks in the class defines the range of your data. Now this range, it usually increases with the increase in the size of the sample. If the sample is high, or you can say that you are taking the sample from the population, and as you increase the sample, this range will increase. It is usually unstable in repeated sampling experiments of the same size and large ones. It is actually a rough measure of dispersion, and it is entirely unsuitable for precise and accurate studies, or rather you can say it is a measure for the raw study. It is simple, it is easy to understand, it can easily be calculated, but you have to check that where you have to use this tool of range. So where you want to calculate the lowest and the highest value, and you want to see the values in between, or the variation between the lowest and highest, you find out this measure range. Mean deviation. If the deviations of all the observations from their mean are calculated, their algebraic sum will be 0. When this sum is always 0, it is impossible to get the average of all these deviations. In order to overcome this difficulty, these deviations are added irrespective of plus or minus sign, and then the average is calculated. The deviations without any plus or minus signs are known as absolute deviations. The mean of these absolute deviations is called the mean deviation, and you can also see this, that how it is calculated in the formula. In the deviations, if the deviations are calculated from the mean, the measure of dispersion is called the mean deviation about the mean. As the matter of fact, mean deviation can be calculated about any average, and for that the absolute deviations from that average will be calculated. Here you can see how mean deviation is computed, and in this you can see the classes, the frequency, the mid values, and the difference between the values and the mean of the data, and you can easily compute the mean deviation. Deviation is not only from the mean, but you can also find out the other types of deviations, and these deviations can be from the assumed mean. These deviations, or the mean deviation, can be from the mode. The mean deviation can be from the median. It is actually a characteristic can be calculated based on a deviation from the mean or a median or a mode. Standard deviation, if you see, is not less than the mean deviation in a discrete series. It is either equal to or greater than the mean deviation about the mean. When an average other than the arithmetic mean is calculated as a measure of central tendency, mean deviation about that average is the only suitable measure of dispersion. Why I am saying so? Because in that you want to see that you have got the central value, but how much a particular quantity or a figure is deviating from the mean, and for that you find out the mean deviation, standard deviation. Now, standard deviation is based on the deviations from the arithmetic mean. In case of mean deviation, the difficulty is that the sum of deviation from the arithmetic mean is always 0. So it is solved by taking those deviations irrespective of plus and minus signs. And when you sum up, see those deviations and you square them and then you sum up and use this formula of standard deviation as shown in the expression, you can find out that how much is the standard deviation. Now, according to this expression 1, the population mean mu is required for finding the standard deviation of a given set of observations. And that given set of observation can be the marks of students in the class. The given set of observations can be the prices of equity of a particular company in a week or in a month, or it can be the mileage of a motorbike or a two-wheeler for 1 month. What exactly you want to calculate, or when you are trying to calculate the standard deviation on any of these 3 parameters, what I have given as an example, you can find out through the value of calculating the standard deviation. Usually or generally the mu is not known. Therefore, it is replaced by x bar, which is the mean of the given set of observation. And then the standard deviation is given by the formula x minus x bar upon n, and you find out the square root of that and you get the standard deviation. What here it means that if you are taking a population, then it is defined as a mu, but if you are taking as a sample, then you take it as a notation of x bar. Here it should be noted that in formula 2, it gives the standard deviation of the given set of data, which itself is assumed to be population with when mu is equal to x bar. Therefore, as the population standard deviation, here I mean to say here is that here the sample and the population are the same, or you have not derived a separate sample from the population. Rather, you are considering the population as a sample or a sample as a population. Now, in case of when the given set of data is not a population, but it is a sample drawn from a large population, the population mean mu is not known. Therefore, in its place, we use x bar as I have told you, which is the estimate of mu obtained from the sample observations. The result is that we cannot calculate the population standard deviation, but we calculate its estimate. We represent the estimates of the population parameters as mu and sigma, which is the standard deviation. And likewise, you can see in formula 5 that the best estimate of the population or the standard deviation can be defined as summation f into x minus x bar upon n minus 1. How you compute the standard deviation? Then for comparing the standard deviation in every case, we have to calculate the arithmetic mean, which increases the labor of calculation work. Therefore, to avoid it, the shortcut method should be used, in which any value of the variate is chosen arbitrarily as a mean, and then the standard deviation is calculated by the following process. In this, you can see that d is the deviation from the chosen mean of each variate, and we try to find out the sum of these deviations and multiply it with the frequency and divide it by the sample size or the population size, and we find out the standard deviation. For this, we require the columns of d, fd, fd square, and in this column, the d, we shall find a factor equal to the width of the class interval, which is shown normally as I. And in that column, we take the other factors is being shown like d upon I or fd upon I and FD square upon I square. With the help of these symbols, we conclude with this formula and we can find out the standard deviation. You can see if summation of FD is equal to I into summation of FD, with this D representing the whole of this bracket, which is summation of FD square upon I square minus summation FD whole square upon N. And by this, we can conclude this formula: standard deviation is equal to I into under root 1 by N summation FD square minus summation FD whole square upon N. Now you can see by an example that how a standard deviation is calculated. You can see the class, you can see the frequency, and since it is the case of a class interval, so in this case we will find out first the mid values of the classes. Like for 0 to 10, the mid value of this class interval is 5. From 10 to 20, it is 15. From 20 to 30, it is 25. And like that, you find out the mid values. Then the frequency is already given to you in the question. And you then try to find out the small d. D is the deviation from the assumed mean, which we have considered as 25. And you can see the d deviation of each variate. And after that, it has been divided in the fifth column. You can see di, or a capital D, which is d divided by the class interval 10. So minus 20 divided by 10, it gives minus 2, and minus 10 divided by 10, it gives minus 1. Like that, we have positive and negative signs. And then multiplying the second column, which is the frequency, with this d, we get FD. And then we square this, and so that the signs get diluted and you get FD square. Now in this FD square, when you put this value, its summation here, so you will get a value FD square minus summation of FD square upon N, and it gives a value of population standard deviation. And when you try to find out its square root, 1850 divided by 15, it's 11.07. And in case of a sample, as I have said, you will not use the value n, rather you will use the value n minus n. The standard deviation, the sample standard deviation comes out to be 11.46 instead of 11.07. And here the values which you have computed, you can calculate each column and do a summation of that and put up into the standard formula given to you, and you can get the value of standard deviation. Characteristics of standard deviation. It is rightly defined that its a computation is based on all the observations. If all the variate values are the same, then the standard deviation will be 0. Standard deviation is least affected by the fluctuations of sampling. It is affected by the change of scale, but not affected by the change of origin. Now you can look at the uses of standard deviation. Standard deviation is used in computing different statistical quantities like regression coefficient, correlation coefficient, and it is in connection with the business cycle analysis. It is also used for testing the reliability of certain statistical measures. And you can also see that how this deviation is calculated to show the overall characteristics of the data. Another type of deviation is a quartile deviation or a semi-interquartile range. This is again a measure of dispersion, and it is expressed in terms of quarters, or you can say the quartile. And this is also known as a quartile deviation or semi-interquartile range. And it is usually calculated with the formula of, if it is the upper quartile and the lower quartile, then Q3 minus Q1 upon 2. It is not the measure of deviation of a particular average. For symmetrical and moderately skewed distribution, the quartile deviation is usually the 2/3 of the standard deviation. So you can also find out 2/3 of the standard deviation, and it will give you the quartile deviation. The next type of dispersion and important is the variance. Now, variance is a very important kind of dispersion. Why I'm saying so? Because it is the square of the standard deviation, and it tells you how much is the exact spread. And why do you try to find out this variance? The variance of a population is generally represented by sigma square, and its unbiased estimate calculated from the sample by the symbol S2 if it is done based on a sample. But why do you calculate the variance? And this can be said that if the variance is more, the disperse is, or the spread is more, and more is the extreme data away from the mean. Suppose we take different marks of any subject in a class and we find out the variance in that, and there may be two subjects, maybe physics and chemistry, and in physics, if the variance is less, and in chemistry, the variance is more, what you have calculated, then what do you conclude out of that? The conclusion is that there may be few weak students in a subject in which variance is more. And if the variance is less, the spread is less, the dispersion is less, then we can say that most of the students are near to the mean. But it depends upon the central value, whether it is on the higher side or on the lower side, what characteristic of marks it is showing of a class. And this also you can see in the next module when you see the kurtosis, or you can see the way their data is represented. Relative measures of dispersion. The measures of dispersion which we studied so far are the absolute measure of dispersion and are represented in the same units in which the observations are represented, like grams, centimeter, meter, hectares. When we have to compare the dispersion of two or more distribution, it will not be proper to compare their absolute measure of dispersion, because the distribution or the data may differ from one and another. And this difference will be with respect to their averages, it may be with respect to their dispersion, it may be with respect to their averages and dispersion both, or it may be with respect, difference may be with respect to their units. Therefore, they will not be comparable. So, in such circumstances, their comparison is possible with the help of relative measures of dispersion. Coefficient of dispersion, it can be computed as a measure of dispersion upon related measures of central tendency, which talks about the coefficient of variation. Now, this is also a very important aspect of the dispersion. Why I'm saying so? Because I'll take you to an example in which you can yourself find out its use. Let me first explain you, this is also a relative measure of dispersion. It is especially important on account of the widely used measures of central tendency and dispersion, the arithmetic mean and the standard deviation. and it is given by the standard deviation upon the arithmetic mean into 100. It is calculated in percentage, and it is used to compare the variability in two or more series. Lesser value of coefficient of variation indicate more consistency. The standard error. Now, standard deviation of a sampling distribution of statistic estimate is known as standard error of that statistic or that estimate. If we take all possible samples from the population of the same size and getting a sample distribution of the mean, it can be proved that mean of this sampling distribution of means in the population mean and its standard deviation, the standard error of the mean, as it is not possible to draw and study all possible samples, we have to get the estimate of the standard error from a single sample. If S be the standard deviation of the sample with a size n, the estimate of the standard error of the mean is given by S upon under root n. You can see the expression of finding out the mean and the standard error. Now, this is the standard error of the mean. Now, this whole module is giving you the picture of the dispersion and the different types of dispersion, how much is the variability and how much is the variability from the central figure, and that is mean. The quartile deviation of the sampling distribution of means is also known as the probable error, and it is used with a value of 0.67449 times of the standard error. Therefore, the probable error is equal to 0.67449 into standard error. 3 times the probable error is roughly twice the value of the standard error. This measure of dispersion has no particular advantage, and moreover it is involved with a troublesome factor what cannot be easily memorized, and that is 0.67449, and that is why it has gone out of use and has given place to the standard error. So the students, let's now summarize what we have learned in this module. This module has provided an overview to the students to understand the techniques that are used to measure the extent of variation or the deviation of each value in the data set from the measure of its central tendency. And these measure of central tendency are what? Mean, median or mode. So such statistical techniques which are giving us to understand that how much this variation are called the measures of dispersion or variation. A small dispersion among values in the data set indicates that data are clustered closely around the mean, and also shows us that how much is the scatter, how much they are away from the mean. The mean is therefore considered as the representation or the central value of the data. We can also say that mean is the reliable average. Conversely, a large dispersion among values in the data, it indicates that the mean is not reliable. If the dispersion is more and the scatter is big, we can say the data is, or the mean is not so reliable. And we can also say that it is not the true representative of the data. The symmetrical distribution of values in 2 or more sets of data may have same variation but differ greatly in terms of arithmetic mean or any other central value. On the other hand, 2 or more sets of data may have the same arithmetic mean, but the values of variation or dispersion may differ. Thank you.